Yeah. So today my prime focus is to complete with one onto many one into problem solving. Yesterday we have done so many questions on one onto. Is there any doubt about which function is one, which function is onto, which is many one, which is not many one? Anybody? All right. So we will start with a very simple question. The question is, write down. F from R minus 3 to R minus 3 fx equals to 3x plus 1 upon 3 minus x upon just a moment, not 3 upon x minus say 3. 3x plus 1 upon x minus 3. Prove that this function is this function is bijective. Yes, tell me. Quickly attempted. Yeah, this is 1 onto, I know, but prove it. Now see, how do we do it? First of all, let x1 comma x2 belongs to domain of the function and fx1 equals to fx2. Yes, fx1 will be 3x1 plus 1 upon x1 minus 3. fx2 is 3x2 plus 1 upon x2 minus 3. Now cross multiply. So 3x1 x2 minus 9x1 plus x2 minus 3 is 3x1 x2 minus 9x2 plus x1 minus 3. Now if you realize this 3x1 x2 cancel, this minus 3 cancel. So what does it become? It became 10x2 is 10 times x1. So x1 equals to x2. Now do you realize this x1 equals to x2 is the only solution we have? Yes or no? So since x1 equals to x2 is the only solution, function is 1. Now for onto into, you will assume y as 3x plus 1 upon x minus 3. Cross multiply xy minus 3y is 3x plus 1. So x times y minus 3 is 3y plus 1. Implies x is what? 3y plus 1 upon y minus 3. Now do you realize y can be anything? except 3. So range is what? Y minus 3. And this range is also given to you as codomain. This range is equals to its codomain. So function is what? Function is onto. Am I correct? So it is a bijective function. Have a look. Am I correct? Well, write down another question. This is a very good question, a previous year JEE question also. The question is, let f from xyz to abc be a bijective function, be a bijective function, bijective function, and only one of the following three conditions, one of the following three conditions is true. The three conditions are: first is fx not equal to b, second fy equals to b, and third fz not equal to a. That only one of these three conditions is correct. Find the function. Yeah, Thanush, what are you saying?
Previous questions.
Previous question, see, yesterday only I explained this kind of question also. See here. Last class also, yesterday we have done this question. So to prove for 1, 1 on 2, we assume
Right.
first of all, like x1, x2 belongs to domain of the function and fx1 equals to fx2. Correct? Then we solve the equation. After solving, if I get x1 equals to x2 as the only solution, this function is 1, 1. All right. Yes. Now think of it. And such a beautiful question it is. Quickly do. Now see, they are saying only one of these three conditions is true. Well, out of these three, only one condition is correct. Let us assume, see, this is an intense analysis question. है ना जो correct है that the correct statement I'm writing in the above column. All right. Say fx not equal to b. This is true. और fy equal to b ये true है. And fz not equal to a. This is true. Now, if fx not equal to b is correct, that means fy equals to b. This is false. And fz not equal to a is also false. That implies कि fz is equal to a. This is correct. Then, if fz is a, fx not equal to b is correct. Fy equals to b is false. That means fy have to be c. Because a is already occupied. Fy is b false hai. That means fy is c. If this statement is correct now, that means fx has to be b. But they are also saying fx not equal to b. Am I correct? That means this entire case goes wrong. Understood, everybody? Now, if they are saying fy equal to b correct, that means fy came b because it is correct. Then they are saying fz not equal to a is false. That means fz is equal to a. That also means fza fyb. That means fx equals to c. So this is a valid case. Got it? Because according to them, fx not equal to b is also false. Fine. Now if I go with the third case, fz not equal to a, if it is true, and fx not equal to b, if this is false, that means fx equal to b. Am I correct? Fx equals to b. Fy equals to b false. That means fy can be a. Fz not equal to a true. That means fz equal to c. This is also going correct. Just a moment. Fy equals to b if this is true. Then fx not equal to a false. That fz not equal to a false means fz equals to a. So fx not equal to b is false. In that case, fx can be c. Bijective function, one of the three conditions is true. Only one of the three conditions is true. If fx equals to f not equal to b is true, that is sorted. Fz not equal to a true. That means fz fy equal to fx equals to b. Fz equal to c. So fy can be a. That is also fine. If fy equals to b true hai, that means fy is b. Fx equals to b. Not okay. There is a mistake. They are also saying that fx not equal to b is false. That means fx equals to b. So fy is b, fx also b. This cannot happen. So this case is also. So this is the only correct case that we are having. This is the only correct case that we are having. That means fx equal to b, fy a, fz equal to c. All right. Am I correct? No.
Again,
Sorry? Ramesh, what are you saying? I did not get you. Your voice is not clear. All right, you just have a look on it. I'll be back in a moment. Ramesh, were you saying something? Okay, now I saw your chat. You are asking for it once again. Okay. Okay. I'll do the entire question once again. These are the three conditions for a 1, 1 onto function. These are the three conditions for a 1, 1 onto function for which they are saying only one of the three statements true. Now see, there are three cases going. Let fx not equal to be true, fy equals to be false, fz not equal to a false, or it can be fx not equal to b false, fy equals to b true, fz not equal to a false. Fx not equal to b false, fy equals to b false, fz not equal to a true. Isn't it the case? They are saying out of the three, only one is correct. Now, if I consider fx not equal to b true, if fz not equal to a false, that means fz is going to be a. Am I correct? Now, fy equals to b false. That means fy can be a or c. A is already occupied by z, so fy equals to c. Now fx not equal to be true hai, then how can fx be a or c? They are already mapped with y and z. Am I correct? So fx has to be b, which is wrong, because fx not equal to b is true. So that is why this case is not working. Now come here, fx not equal to be false. That means fx is b. Fz not equal to a false. That means fz is a. Now fy also b. Fy also be true. Is it possible? Though elements, they are two elements, they are having same image. So this is also wrong case, wrong case. Come here. Fx not equal to be false. That means fx has to be b. Fy equals to b false, fz not equal to a true. So if fz is not equal to a, so then fz can be c. because B is already an image of X. So in that case, Fy has to be A. Now the images are A, B, C. Am I correct?
Yes, sir.
Now, write down another question. F from R to R, Fx is execute. F from R to R, Fx equals to x cube minus 6x square plus 11x minus 6. Check for 1, 1, many 1, on to into. Yes, tell me. F from R to R, this function. Yes, Lakshmi, this is 1, 1 or many 1?
Many ones, sir.
How come did you get to know about it?
It will have more than two roots, sir. One root.
Exactly. If you remember, this is a very popular cubic polynomial, that is x minus 1, x minus 2, x minus 3. Am I correct? And I know f1 is also f2, that is also going to be f3, that is going to be 0. So it is a many one function. Am I clear? And if I talk about onto into, since it is odd degree polynomial, range is going to be R, that is also codomain. So function is on to. Am I correct? Got it? Done? Another question. F from R to R, fx is x cube plus x squared plus 3x plus sin x. Okay, before we proceed this question, remember one thing. Yesterday I told you, if a function is always increasing, here only. If a function is always increasing, it will be 1, 1. Always decreasing, it will be 1, 1. But if a function is increasing, decreasing, increasing, like this, first question, the behavior of first question, like this, then it will be many one. Yes or no? So now I'm going to tell you one more info, which we are going to do in AOD chapter. If a function is always increasing, its derivative f dash x is going to be greater than 0. And if a function is always decreasing, then its derivative is going to be less than 0. Always increasing means derivative more than 0. Always decreasing means derivative less than 0. Am I correct? Now, this is your fx. If I calculate here f dash x is going to be 3x squared plus 2x plus 3 plus sin x. I can also write it like 3x square plus 2x plus 1 plus 2 plus sin x derivative is cos x. I hope that much of derivative you are already aware. You must have done it in physics also. Yes or no? Now tell me, what about this? Is it always greater than 0? 2 plus cos x? Because the range of cos x is minus 1 to 1. If you add 2 to it, it will become 1 to 3. So 2 plus cos x is always more than 0. Am I correct? If I see this quadratic polynomial, its d is less than 0. So in a quadratic polynomial, if discriminant is less than 0, this expression is also going to be more than 0 because coefficient of x square is also positive. Remember this thing about a quadratic. If a quadratic expression ax square plus bx plus c you have, if a positive, b negative, implies ax square plus bx plus c will be more than 0. If a negative, d negative, that implies that ax square plus bx plus c will be less than 0. Am I correct? Is it okay?
Yes, sir.
So here, this quadratic is greater than 0, as well as this 2 plus cos x is greater than 0. That means this f dash x is greater than 0 for every x that belongs to number line. Yes or no? So if derivative is positive, that means fx is always increasing. So function is 1, 1. Again, am I correct up to this point? Now, half of the portion of this fx, it is x cube plus x square plus 3x plus sin x. If you see, this is a cubic polynomial. And this is trigonometric, which belongs to minus 1 to 1. Yes or no? Now that cubic polynomial, that is going to take very large values also. It is going from minus infinite to infinite. What sin x is going to make it? Adding plus 1 or minus 1 at times. But this cubic is always dominating and make its range R. Got it? Cubic range R. So for fx, range is R. Am I correct? Am I correct? Bolo, is it okay? Now, write down the next question. F from R to R, fx equals to 6 to the power x plus 6 to the power mod x. Got it? Check for 1, 1, many 1 onto into. Yes, quickly. Anyone on two. Lakshmi is saying anyone on two. Okay. Fx is given to you as 6 to the power x plus 6 to the power mod x. Now see, if x is more than 0, this will be 6 to the power x twice. If x is less than 0, this is 6 to the power x plus 6 to the power minus x. Correct? So I can say if x is greater than 0, it is 2 times 6 to the power x. If x is less than 0, it is 6 to the power x plus 1 upon 6 to the power x. Fair enough? Now, if I see the graph of this function, when x is more than 0, it is 2 times 6 to the power x. Graph is going to be like this. This point is 0, 2. Fine. If x is less than 0, let us assume x is minus 2. Correct. If x is minus 2, this value will become very large and will become 6 square. Yes or no? So the graph in this case at infinite minus infinite, it is going to be this. 0 at 0, it is 1 plus 1. Just a moment. At 1, it is 6 plus 1 by 6. So the graph is going to be something like this. In the left of 0, 6 to the power 1 plus 1, 2. Graph is going to be something like this. Not increasing in the same fashion, but yes, it will also be increasing. Got it? So a line parallel to x-axis will intersect at multiple points. So function is many one. Am I correct? Range also you can see range is 2 to infinite. Codomain is given to me as R. Range is inclusive of 2 to infinite. Codomain is R. So function is into. Am I correct? Write down another question. F from R to R, fx is x square minus 4 upon x square plus 1. Check for 1, 1, many 1 onto into. Okay, I ask you to answer this question without even using your pen. Is it 1, 1 or many 1? Simply tell me. Just quickly, quickly. Tell me, what is F2? Very easy to check. Lakshmi, that is fine. I'm asking for 1, 1, many 1 first of all. What is the value of f of 2? Is it going to be 4 minus 4 upon 4 plus 1, that is 0? And what is the value of f of minus 2? That is also 4 minus 4 upon 4 plus 1, 0. So since f of 2 is equals to f of minus 2, this function is many one? Yes or no? This function is going to be many one. Now, if I talk about onto or into, yes. So see, its denominator is never going to be zero. Or is it? X square plus 1, denominator is never going to be zero. Power of numerator is also power of denominator. So since the denominator is never going to be zero, this function will never approach to infinite. Am I correct or wrong? Since denominator is never going to be zero, this function is never going to be infinite. If it is never approaching towards infinite, its range is definitely not R. Whatever the range is, but range is not R. Range is not R. Calculating range is not so necessary for me. What is necessary? Is range R? The plain answer is no. So since range is not R, which is equal to its codomain, this function is into. Am I correct? Next question. Say fx equals to x plus root x. F is defined from R to R. Root x square. Fx is x plus under root of x square. Tell me, is it 1, 1, many one, on 2 or into, whatever it is? Realize this function fx is, can I write it x plus under root of x square is not x, it is mod x. So this function is x plus mod x. Yes or no? No. If x is more than 0, it is going to be 2x. If x is less than 0, it is x minus x, which will be 0. If you draw its graph, that would be something like after 0, it is 2x. Before 0, it is like this, 0. So certainly it is many one function. Its range is going to be, which is not equal to codomain, that is R. So function is into also. Have a look. Understood, everybody? Write down another question. F from R to R, fx equals to 2 to the power x minus 2 to the power mod x. Check for 1, 1, many one, onto into. Yes. Quickly. Yes. Many one, very good. Onto or into? See, if you design this function, if x is greater than 0, it is going to be 2 to the power x minus 2 to the power x. And if x is less than 0, it is 2 to the power x minus 2 to the power minus x. So that means if x is more than or equal to 0, it is going to be 0. If x is less than 0, it is going to be 2 to the power x minus 2 to the power minus x. Am I correct? Now see, let me consider another function hx as 2 to the power x minus 2 to the power minus x. See, if you calculate h dash x, derivative of 2 to the power x is 2 to the power x ln 2. It will be 2 to the power minus x ln 2. So it is 2 to the power x plus 2 to the power minus x ln 2, which is greater than 0. So if it is greater than 0, that means this function hx is always increasing. Now, if I draw its graph, when x is more than 0, this function is 0, straight line. When x is less than 0, it is going to be increasing. Means something like this is happening. Yes or no? Like this is happening. That means what? Many one. Because at every positive value, it is 0. And definitely it is into also. Because codomain is given to me R, whereas the range is minus infinite, say 0. Am I correct? Am I correct? So it is many one into. So let's keep it up to this point today. I will look at the questions once again. We started with this question, a linear by linear type question, which where I expected you to prove it as a bijective function. We did again same thing. X1, X2 belongs to domain of the function and fx1 equals to fx2. Then we made an equation. We simplified that equation. Now x1 equals to x2 is the only solution we received. This function is 1, 1. Then y is given to you. You have written x in terms of y. And you got the range which is equal to codomain also. This function is onto. Got it? Then this question where out of the 3 statements, only one is true, other 2 are false. So we made 3 situations where if this is true or second one is true or third one is true. And out of that, we got one conclusion. Now it is a cubic polynomial. The polynomial is simply written as x minus 1, x minus 2 and x minus 3. At 1, 2, 3, the value is going to be 0. So this function is many one. Now, odd degree polynomial range is R, that is also codomain, function is onto. Then this question, then 6 to the power x plus 6 to the power mod x. Then this, and finally we did this question. Is there anybody who want me to repeat any question which you did not understood? Anyone? I hope I have been able to make you understand almost everything. Is it okay? Well, that's it from my side for today. Tomorrow we'll start with their composite functions. All right. Thank you so much.